review two-step equations, and then we're going to do some more advanced two-step equations. Are you ready? So let's go ahead and take a look. So first question is, if I have an equation that looks like this is a one-step equation. Question is, can you solve for x? Okay, can you solve for x? Okay, there's no worksheet for today. No worksheet for today. Whatever I'm writing down, that's what you're writing in your journal. Okay, good. All right, how many people can just do this one in your head? Right? Okay, if you can't, that's okay. We want to see what the pattern is. So whatever is in front of the x that includes the negative sign, that's what we're going to divide by. And you can't do it just to one side. You have to do it, whoop, that's supposed to be a line. You have to do it to both, okay? So -3 over -3, that's another way of saying 1, okay? Because the numerator is the same as the denominator. And we have a positive and a negative. So that means our answer is negative. 3 goes into 36 12 times. Yay. All right, you warmed up now? Okay, let's try another one. So what about x minus 3 equals 3? Can you do this one for me? X minus 3 equals 3. Okay, so at addition and subtraction instead of that multiplication. Some of you are saying 0, some of you are saying 6. So if you try to do this in your head, half the time you won't get it right. Just because we're new at this, right? It's like the first time you rode a bike, little wobbly, right? Good thing there were training wheels back there. Same thing with algebra. Okay, so I need to get this term over here. And the way I do that is by adding 3. So whatever the sign is, it's going to be the opposite. If this was x plus 3, this would be minus 3. Okay, so it's x minus 3, so it's going to be plus. Whatever you do to one side, you have to do to the other. So -3 plus 3, that's 0. Plus 3 and plus 3, right? If it doesn't have a sign, we call that plus, is going to be 6. Give me a smile if you're seeing this now. You're like, aha, okay, I get it now, Aurora. Thank you so much. All right, great. Let's try this one. -4 equals 5 plus x. Okay, -4 equals 5 plus x. Okay, quick review. Think about what we just talked about. Take it slow. Okay. Good question. Somebody's saying, does the x always have to be on the left? No, it just has to be by itself. So in order for x to be by itself, we have to get rid of the 5 and put it over here. To get rid of the 5, we subtract 5 because this is a positive, so this is a negative. But whatever we do to one side, you have to do exactly the same on the other. Okay, so this is plus 5 minus 5, that's 0. So we just have an x. 4 and 5, these are both the same signs. We combine them. X is equal to -9. Good. All right, how about one more review? I have x over 5 equals 4. What do you do now? Okay, Brooklyn, this one's for you. Okay, take your time. Okay. All right, how do you get rid of this? Does it help you if I put it like this? This is exactly the same thing. These are identical, okay? How do I get rid of a 5th? How do I make that go away? So when it's multiplication and division, we want this to go to 1. When it's addition and subtraction, we want this to go to 0. You see the difference? So you don't want this to go to 0 because that'll cancel out your x. Okay, so what we want to do, somebody said multiply by 0. That doesn't help. So if I multiply by the reciprocal of 1/5, which is 5 over 1, okay, or just 5, okay, 5 over 1 is the same as 5. Do you see how this cancels? And we get 1. 1 times x is x. That's what we want. 4 times 5 is 20. Give me a smile if this makes sense, even if you didn't get it on your own the first time. Yeah? Yay! Okay, time to kick it up a notch. Those were all one-step equations. Let's do two-step. Okay, so now we're in second gear here. I have 2x equals 24 minus x. Okay, so this is going to take us 2 lines at least. Okay, so how do you know what to do first? So the first thing we do is we collect terms. That's our first step. Collect, they call them like terms. Okay, like in this case means you put the x's on one side and the things without the x's on the other side. Okay, so I see a 2x here and a minus x here. You see that? So I'm going to say plus x plus x. That will get rid of this. So all I have is a 24 on that side. What is 2? Now, if there's nothing in front of it, we call that a 1. 2 plus 1 is 3, but don't forget the x. Okay, and then step 2 is you want to solve for x. So how do we solve for x? We divide by whatever is in front of the x, including the sign if needed. So we're going to divide by 3. So we have x on that side. What do we have on this side? So x is equal to 3 goes into 24 8 times. Let me back up the camera just a little bit for you. Okay. How does that look? Okay. So the x is not squared because, that's a good question here. If I have 2x plus x, what that's saying is there's 2 of these, x plus x, that's 2x, plus another one. So we call that x, that's 3x. The x is squared if you do this. Okay, what does that mean? This means 2x times x. Do you see the difference? Okay, in this case, we're adding them. Okay, so you have to think about what does this thing really mean? It just means I have an x and I added another one. This one, we are multiplying by x, so it's 2x squared. We're not going to get into this until later in the year on how to solve for those. That's a little bit more complex. Okay, so for us, we're going to keep it linear. That means x, the highest power we're going to deal with when we solve for x is just to that first power. Okay, let's try another example. Good question. How about this one? 5x equals 7x minus 1. Okay, what was our first step? Do you remember? We collect like terms. Good. Okay. So how are you going to do that? I have an x on both sides. Somebody's asking, can I divide by 7? Well, if you divide by 7, you're going to get a mess because this one doesn't have an x term. So it's going to make your life harder. So instead, think about this. The first thing I'm going to do is addition and subtraction. So if I subtract 7x and I subtract 7x, do you see how that gets all the x's on one side and then leaves the numbers on the other? So plus 7 minus 7, that's 0. So I'm left with just a negative 1. Okay. 5 minus 7. So the 7 is bigger, so we have a negative sign. The difference between 5 and 7 is 2, and don't forget the x. Okay. All right, everyone good here? Give me a thumbs up. We're good with this step. Can we keep going? Okay, ask me questions if you have it. Okay, then we're going to divide by whatever's in front of the x, including that negative sign. What do you get? There we go. Now I'm seeing it. X is equal to, this negative over negative is a positive, so that's going to give me x equals, negative over negative is a positive. X is equal to 1/2. We're going to do lots more examples. Okay, so I'm going to pause here for a second. All right, so look at what we did. The first thing we did was we wanted our x's on one side. Somebody's asking, could I put the 5 over here and the 1 over there? Yes, if you're careful, you're going to get exactly the same result. Okay, I chose to put the x's on the left and have the numbers on the right. It's up to you how you want to do it. Okay, but for me, I want to do it all in just one step. Okay, so I'm going to, I subtracted 7 from this side. minus 7x here, and I'm basically taking that 7x and I'm throwing it over here. So 5 minus 7 is our minus 2. And then the next step is we need to divide whatever's in front of the x. In this case, it's going to be this negative 2. So negative 2, negative 2. So I basically need x by itself. So x is equal to, and then this is the minus 2 from over here, right? Okay. Who would like another example? How about we do a bunch more? Okay, sounds good. So